Hi scholars, Mrs. Avedian here, so that we can go on to our next page in the packet, which is page 9 and 10. So these kind of go together. They should be able to be done in less than an hour, so you should be able to do them on one day. They are, again, continuing to review and use our exponent rules that you've learned. So I have the exponent rules here on the page. If you don't have them written down, it's going to make this page a lot easier to work on. A lot harder, not easier. So your exponent rules, you can pause right here if you need to write these rules down. And then I'll move up. These are the rest of the rules down here. Oh, let me make it so you can see these better. Sorry about that. I know they're not inside the little window there. I think you're not able to see the ones at the very bottom, so I will stretch this out so you can. Ta-da! There are the last ones. The identity exponent, the power of a quotient exponent rule, the negative exponent rule. Okay, so make sure you've got those written down if you don't already. Now let's go ahead and look at the page that you're working on. Again, this is page 9 and 10 of your packet. Page 9 and 10 are really the same exact things. It's just more practice of them. And you want to make sure that you're watching the videos because I will tell you if there's something you don't have to do. That's always useful. So let's take a look at this first one. This first one, you've got multiplication. So if you're looking at your rules, I'm going to pull these up here for again for a second. If you're looking at your rules, multiplication is this product of powers rules. So it says I add the exponents. So let's go ahead and look at this. Oh goodness. Why did it zoom out? Okay. So on here, my exponents are 5 and -4. So 5 plus -4 is -1. So this is going to be 4 to the -1 power. So you can write that over here as 4 to the -1, or you can go ahead and expand that further. So if I look at my rules, my rule for negative exponents, I'm going to scroll down here. Here's my rule for negative exponents. X to the -1 power, or the -n power, is the same as 1 over x to the positive power. So you can write it as, back over here. I could also write this as 1 over 4 to the first power, and 4 to the first power is just 1/4. So I could also write this as 1/4. So it's up to you which one you choose to write that as, 4 to the -1st power, or 4 to the negative, or just 1/4. That's using all of our rules there. So that's really what's different about this page than the one we did before, the two in the front, pages 1 through 4 of your packet, is now we're using a lot of negatives on this one, a lot of negative exponents. Let's try out a couple more of these. I'm going to go ahead and do every 5th problem so you have some good examples. So let's take a look at this one. Number 5, 7 to the -4th power multiplied by 7 to the 10th power. That's our same rule. We are adding the exponents. So this is equal to the 7 to the -4th plus 10th power. And so -4 plus 10. Okay, so I'm taking 4 away from 10. So that is 7 to the 6th power. You're not going any farther to that. You're not expanding these all the way out and using a calculator to figure out what 7 to the 6th power is. You're just simplifying this. It's not asking you to go any farther than that. We're trying to use the least number of bases and make it as simple as we can. Okay, let's go down and do all the way down to number 10 now. Again, you're going to fill in the blanks in the middle. I'm doing every 5th one with you to help you out. So we have 9 to the -4th power times 9 to the 0 power. Oop, we got a new power rule. What is 9 to the 0 power? Let's go ahead and look at our rules sheet. Let me flip over here. I have something to the 0 exponent. Okay, it says anything to any number, so any x, any number, to the 0 power equals just the number 1. Okay, so if I have 9 to the 0 power, that's just the number 1. So this is 9 to the negative 4th power times 1. And 1 times anything is just itself. So that is just 9 to the negative 4th power. Now, if I want to take this further and get rid of the negative exponent up here, then I could rewrite this as 1 over 9 to the 4th power. That gives me a positive exponent. Anytime you see the negative, you're just going to take and put 1 over, and then whatever this base is, and then the exponent becomes positive. Okay? So now let's go to number 15. Number 15, you have 12 to the 3rd power times, and you're raising it to the 10th power. 12 to the 3rd power raised to the 10th power. So we've got another new rule here. And again, all these rules are what we practiced in class that you should have these notes on. So let's look at, okay. So we have a power raised to another power right here. So it says that I need to multiply those two exponents. So if I have a power raised to a power, I can rewrite it with those two exponents multiplied by each other. So if I have 12 to the 3rd power raised again to the 10th, I can rewrite this as 12 to the 3 times 10th power. 3 times 10 is 30. So I'm going to write this 12 to the 30th power. Okay. Now let's go ahead and down here and do number 20 together. Number 20. So I have 1/2 raised to the 9th power. Let's go see if I've got a sample on my sheet of rules that looks like this. That's a fraction multiplied to a raised to a power. Okay. Oh, I see a fraction here. But that's really quotient. That's not the whole fraction being raised to a power. It's got two different powers. Let's see if I've got another one. Okay, here. I've got a fraction here being raised to a power of m. And it says that I could rewrite that as whatever my numerator is to that m power divided by whatever my denominator is to the m power. So let's go ahead and try that. So I have 1/2 to the 9th power, so I can rewrite that as 1 to the 9th power divided by 2 to the 9th power. Okay, 1 to the 9th power divided by 2 to the 9th power. And 1 to the 9th power is really just 1, because 1 times 1, 9 times, doesn't matter how many times you multiply 1 by itself. So I could really just write this as 1 over 2 to the 9th power. I really just do that. No reason to have that 1 to the 9th power, because 1 multiplied by, it doesn't matter, 1 to the 1290th power is still going to be 1, because 1 times 1 is always 1, times another 1 is always another 1. Okay. Again, you're doing the ones in the middle to show me that you're learning from what we're doing. And this is nothing new. We've done this at class too, and that's why you have your notes and your rules that we did in class. I know you probably didn't take them home with you, so we'll go over them again. Now we've got 3x raised to the 7th power. Now there's something different about this one because I have 2 numbers inside of the parenthesis being raised to the 7th power. So let's go ahead and look at our rule sheet. Okay, I'm looking for something with more than one thing inside the parenthesis. So not this thing, because this thing has an exponent inside the parenthesis. My sample didn't have an exponent. It had two different values inside of the parenthesis raised to a power. And it says, oh, so I need to take whatever this first value is and raise it to the m power. and then whatever that y value is and raise it to the m power. So let's apply that to our problem here. So number 25. 3, so it says that my 3 here needs to be raised to the 7th power. So I'll go ahead. And my x needs to be raised to the 7th power. It's distributing across both of those. Both of the factors inside of the parenthesis. Okay, so both of those things need to be to the 7th power. Okay, let's go ahead and come down to number 30. So this is that same rule that we did over here. We've got a power to a power. And so when we've got a power to a power, so power to a power, we have to multiply those two things. So this one's a little tricky. We have 0 times 50. So this is the same as 22 to the 0 times 50th power. 22 to the 0 power, 0 times 50 is just 0. So this is equal to 22 to the 0th power, because 0 times 50 is still just 0. Anything times 0 is still just 0. And anything to the 0th power is just the number 1. 1. So I think you could probably do these. I think you can get that one, because it's, you got 0 to 22 to the 0th power raised to the 55th power. Another way I could look at this, I've got 22 to the 0th power in here. Anything raised to the 0 power is just the number 1. So really what I've got inside those parentheses is just the number 1, and that's being raised to the 55th power. And again, like we said before, 1, I don't care how many times you multiply 1 by itself, you get the number 1. You can multiply 1 by itself till, for millions of times, and you're still going to get the number 1. Okay. Let's go down here now to number 35. And we've got 1/11 raised to the -7th power. Now we already did one that was a fraction raised to a positive power. We got a fraction here. Okay, raised to a positive power. And we just took the fraction and we multiplied the top number times that and the bottom number times that. Okay? So we're just going to take this one here, and we're a little trickier here. And this, I'm going to tell you, if you're watching this video, that these 3 problems right here are challenge problems, because I want you to think about what this might do to it. We've said that what we end up with when we've got a negative exponent, your rule for a negative exponent, let's look at that. A negative exponent is really the same as 1 divided by the positive exponent. Okay, 1 divided by the positive exponent. We're going to see if we can do something to this. I want you to also think about this rule over here. Let's see. When we've got quotient of powers and we have a different power on the top and the bottom, and we can subtract those from each other. So we're going to end up with some interesting things that happen here. And I want you to, I'd love for you to try those fractions raised to the next negative exponent. But that is not an 8th grade standard that you know how to raise a fraction to a negative exponent. So I'm going to let you see if you can figure that out. Email me if you figure it out. And then we'll chat about that some more. Okay. Now we have fractions that are each raised to an exponent. And so when we have fractions raised to an exponent, what we have to do is we have to take the top number. So we're taking the 56, which is our base. And then we're taking our numerators. So -23, the numerator's power, and we're subtracting the denominator's power. Okay, so we're subtracting 34, -34. So we had -23 minus -34. It is okay if you use a calculator when you have something like that. just be forewarned that, you know, remember your rules when we learned about subtracting integers. Subtracting a negative is the same as adding. So what we've really got here is negative 23 plus 34. So I'm going to count up from 23 to see what the difference is between 23 and 34. So 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So that is 11. So I'm going to end up with the 56 to the 11th power. I know it's positive because this 34, let me use a different colored pen. Do I have a different colored pen? I'm going to use a pencil just so you can kind of see this. Because when I subtract a negative, I end up with a positive. I end up adding. And when we take a negative number and we add a positive number, we find the difference between those two numbers. 11 was the difference. And it gets the sign of the number with the greatest absolute value. 34 is a greater absolute value. It's farther away from 0 than negative 23 is. Or 23 is. Okay? So that's why we have 56 to the 11th power there. These get to be kind of tricky in here. Okay. Now we get down to number 40. And on number 40, I'm going to tell you that I'm going to do number 40 with you, and then I'm going to tell you that the rest of these are all challenge problems. You do not have to do them, but if you do them, email them to me, show me what you got, see how you did. It's always good to challenge yourself. Okay, so I have that same rule we had in the beginning, where we've got the same base. We've got negative 2 and negative 2. So, and we're multiplying, so that means we're just adding our exponents. So negative 12, this would equal negative 2. I put it in parentheses because I want this negative to stay with the 2. To the negative 12 plus 1. So negative 12 plus 1 is going to give us negative 2 to the negative 12th power. Okay? And you can write this as a fraction as well if you wanted to go farther. And you could say this is 1 over negative 2 to the positive 12th power. So you could write it either way. Depends on how far you want to take it, how much you want to challenge yourself. Okay. The next page, page 10, is exactly the same kinds of rules. So challenge yourself to see as far as you can get. If you're finding that these two pages together take you more than 1 hour, then call me. We can chat about which problems you absolutely have to do, what are your must-dos, and we can customize this lesson for you, but you have to show me that you're learning some of the rules on your own and be able to talk about it. And call me. Okay? I will go ahead. Your next lesson is on scientific notation, and your next video will cover page 11, which is just directions, and then pages 12, 13, 14, and 15, which is the actual lesson on scientific notation. So that will be your next day's work.